Okay, so in this video, we're going to go through the exercises that I basically gave you for homework. Otherwise, you can also find them in the description down below. Okay, so the first one went, well, it was something like this. So determine the elements of sets A intersection B, then, okay, then B dash without A, and so on. So A intersection B, this is basically a set that contains the elements that both A and B have, meaning the elements that they have in common. In this case here, those are the ones, so 7 and 8. Then we have B dash without A. If we remember, B dash, that was everything outside of A. So you see this is a universal set, and B dash, meaning it's like cutting that B out of that universal set. And then you take A away from that also. So everything outside of B and without A. And well, if you think about it, the only thing that you will get is 1, 2, 3, and 9. So basically all the elements outside of A, outside of B, and well, outside of A as well. 1, 2, 3, and 9. Then you had to determine this one. A union B without A intersection B. And then this notation here. This basically means the cardinality of this set here. Cardinality means the number of elements that this set in here has, the underlined set. So A union B, that's whole of A and B, 4, 5, 6, 7, 8, and then you take A intersection B out, meaning you'll get 4, 5, and 6. Okay, and now the answer to this one is easy. The cardinality of this set, well, it's 3. Okay, then B times A without B. You see, this is a Cartesian product, meaning the set of all ordered pairs of elements. Well, the first element is from B and the second one from A without B. Maybe if I just write it out, B has elements 5, 7, and 8 times, and A without B, that would be 4 and 6. And now you have to make a set of all ordered pairs, meaning first, for example, will be 5, 4, then the next one 5, 6, 7, 4. Okay, you can just write a normal comma or this one. 7, 4, 7, 6, and so on. You see 8, 4, and 8, 6. Okay, and now the power set. This is the power set of B. Power set of B, if we remember the definition again, this is a set of all possible subsets of a set B, with the empty set and B included. So the empty set will be in. Now all the possible subsets. You see, so this is the set that contains sets. So 5 will be in, 7, and for example 8, and then I'm gonna make pairs 5 and 7, 5 and 8, and 7 and 8. And you see all the set B, 5, 7, and 8. 5, 7, and 8. So it has to have 8 elements. Let's check it. 1, 2, 3, 4, 5, 6, 7, 8. It works. So basically, this was your this was the first exercise from that homework. Okay, so the next one. In the next one, well, you had to determine the elements of some sets. And well, maybe if we do the M and O, and this probably should be a P. So the M, what elements does it have? If we just read this set out, okay, those are natural numbers, meaning the numbers that we count with, 1, 2, 3, 4, 5, and so on. This basically tells you 4 divides them, meaning they're divisible by 4, and they're between 8 and 25, with 25 included. So all the natural numbers that are between 8 and 25 and are divisible by 4. The first one would be 12. You see, we don't take 18. So 16 and 20 and also 24. Those are all the elements between 8 and 25, not 8, because there's not a line under there, that are divisible by 4. And now you see, you don't take those elements, but you subtract 5 from them. So you subtract 5 from them. This is basically what this set tells you. 12 minus 5, that's 7. 11. 11 is 16 minus 5. Then 15 and 19. And this is a set n. Let's see for set n, if we read it out again. So n should be a prime that's less or equal than 25. Those are 2, 3. Then the next one would be 5, 7, 11. And there's quite some. 13, 17, 19, 23, and this is basically it. And you see, what you're going to do is you're not going to take those elements, but this tells you that you have to multiply them by 2 and subtract 1 from them. Multiply them by 2 and subtract 1. 2 times 2 minus 1, that's 3. 2 times 3 minus 1, that's 5, and so on, you see. 2 times 5 minus 1, 9. 2 times 7 minus 1, that's 13. 2 times 11, 22 minus 1 is 21. 25, 33, 37, and 45. You see, to all of those elements, I just multiply them by 2 and I subtracted 1 from them. The next one, you see, are basically all the integers that are solutions to this number here. Let's maybe first solve this equation here. So I'm just going to put 1 on the other side and divide the whole thing by 2. I will get n is equal to minus 3. And now again, you see, this tells you not to take minus 3, but to add 2 to it. So you will add 2 to this one here, and you will get minus 1. And this is the only element of set A. Set O. O is called a singleton. That's a set with only one element in it. Okay, and the P. The P is basically, you see, this one tells you all the squares that are, all the numbers, all the integers that if you square them, you get something less than 16. Those would be, well, 0, 0 squared is less than 16. 1, 2, 3, and 4. 4 squared is 16. That's still counted in, you see, because of this line here. And then on the other side, you have minus 1, minus 2, minus 3, and minus 4. This is minus 3. So again, you're not going to take those elements. You're going to multiply them by 7 and add 1 to them. So this will be minus 27, minus 20. 7 times minus 2, that's minus 14, minus 13. In the end, minus 6, 1. And then you have 7 times 1 plus 1, that's 8. Well, do you see what we're doing? We're basically just adding 7. Add 7, add 7, and so on. So the next one will be 15. This is with 2, and 21, 22, and 29, and those should be all of the elements. Okay, and this was the second exercise already. The third one, you had some sets that were given, and well, you basically had to express the colored sets here. Those are the ones that are colored in reddish color here, and you only had to use unions, intersection, and this is without, and the dash, meaning B dash, everything outside of B. Well, in this case, dash doesn't really come into account because we don't have those kind of caught in a universal set. So basically just union intersection, and without. Okay, let's try and do this. So first thing, maybe the green one here. You see, those are all the elements that A and B have in common. So this is A intersection B. The next one would be, let's say, yeah, okay, you can see it clearly. So this one here, you see the red elements, those are all elements that only C has, only set C has. So basically C without, you see there's some B in and some D in. So I'm just gonna take that out. Not A, but I'm gonna take out B and D. So C without B union D. B union D. That's the red set here. And then the last one, let's say with purple, you see those are all the elements that D has, and you see there's no C in. So basically D without C. Okay, so we managed to express all the parts separately, and what now? Well, we have to put them together somehow, and we'll do it using unions. This union, this union D without C. Okay, and that was the third one already. And the fourth one, you see, you had to color those sets. The first one, let's say this will be the first one. This is A, this is B, and this is C. Okay, so the first one, A union B without C. So everything that A and B have, but C doesn't. Everything that either A or B have, but C doesn't. So this should be the colored set. You see, A union B would be everything of A and B, and then you take everything that C has out of it, and you will basically get this one. So this is a green one. The red one, let's say this one here, A intersection C, A intersection C. That's this whole part here, this whole part, and then you take away C union A intersection C. So from this one here, you take away all the A union C, meaning basically all this. From red one, from the elements of red, or you can paraphrase it some like this. Which are the elements that the red set has and green doesn't? Well, there's nothing really. None of the elements are like that, right? So how would you color this? You wouldn't color anything, because since this is an empty set, the result of this is empty set, and you wouldn't color anything. So the final solution is something like this. Okay, and what about the last one? The last one, let's say with, I don't know, with purple again. A intersection B intersection C. Those are all the elements that all the sets have in common. Union B without C union A, meaning B without C union A. And how can I read this one? You see, those are elements that B has, and neither A or C do, meaning the elements that only B has. That would be this one here. And you see there's a union in between, so this is the set that we were searching for. Okay, and that was it for your last homework.